The next isotope is the deuterium. Coming to the percentage of this deuterium, the remaining percentage of hydrogen atom contains two other isotopes. The one containing one proton and one neutron is called the deuterium, which is designated as 1d2, and its percentage is 0.015%. The other one possessing one proton and two neutron is called the tritium. It is designated as 1t3 or 1h3. This tritium is found in traces of amounts on the Earth's crust. So therefore, among the isotopes of hydrogen, the most abundant isotope is protium only. So what is the cause of isotopes? So the cause of these isotopes is the difference between the isotopes is due to the presence of different number of neutrons present in the nucleus. So because of the different number of neutrons present inside the nucleus, so it has different types of isotopes. This is the cause of occurrence of different isotopes in any element. Another aspect of atoms is isobars. Atoms with same mass number with different atomic number are known as isobars. Look at the example: 6C14, 7N14. 6, 7. These two represents the atomic numbers of the two elements, whereas 14, 14. These two are the mass numbers of the two elements. Here, the mass numbers of these two elements are same. So therefore, these two are said to be isobars. Using this knowledge of subatomic particles, let us try to solve some model questions. The first question is, the increasing order of specific charge of electron, proton, alpha particle and neutron is. The options are, the first one, electron, proton, neutron, alpha. Second one, neutron, proton, electron, alpha. Third one, neutron, alpha particle, proton, electron. And fourth one, neutron, proton, alpha particle and electron. The ratio of charge to mass is called the specific charge, as I already mentioned about this. So among the given species, alpha particle, the alpha particle is represented as 2He4. This is the representation of the alpha particles. Is having higher mass among the given species. The alpha particle is having higher mass, so it has a minimum specific charge. You know, this specific charge is E by m. When mass is higher, it has less specific charge. So therefore, and coming to the neutron, neutron is a chargeless particle. So that means the charge of the neutron is assumed to be 0. So therefore, it has a minimum specific charge among the given species. Therefore, the increasing value of specific charge is given by keeping in mind the electron is having higher specific charge than proton. Therefore, the increasing value of specific charge is given by neutron less than alpha particle less than proton less than electron. So therefore, electron is having highest specific charge. Hence, the correct option is 3. Next question is, the ratio between the number of neutrons present in C12 and Si30 atoms is. Here are the options. The first one is 3:8, second one is 2:5, third one is 3:7, and fourth one is 1:1. Here, the number of neutrons is calculated using the formula is equal to A minus Z. Here two atoms are given. First one is the mass number for C12. The mass number A is equal to 12. The atomic number Z is equal to 6. Hence, the number of neutrons is equal to 12 minus 6, which is equal to 6. Whereas, for the other atom, silicon 30, the mass number is 30 and atomic number Z is equal to 14. Hence, number of neutrons is equal to 30 minus 14, which is equal to 16. Neutrons ratio between C12 and silicon 30 is 6:16 or 3:8. So this is obtained after cancelling 2 in these 2. So therefore, the correct option is 1. Next question is, the Z and A values of an element are 25 and 55. The number of electrons, protons and neutrons in its most stable ion respectively are. Here are the options. The first one is 25, 25, 30. Second one is 23, 25, 30. third one is 22, 25, 30, and fourth one is 20, 25, 30. The atomic number Z itself indicates the number of electrons or the number of protons. So for the given species, given the atomic number Z is equal to 25 and the mass number A is equal to 55. The number of electrons is equal to number of protons, which is equal to 25, because these two particles, that is electrons and protons, are having same in number for any element. Now the number of neutrons is equal to, the formula is A minus Z. So here A is 55, so therefore 55 minus Z is 25, which is equal to 30. The number of electrons and the number of protons are 25 and 25, number of neutrons are 30. Hence the correct option is 1. Next question is, magnitude of deflection of cathode rays in discharge tube is more when? Here are the options. The first one is magnitude of charge of the particle is more. Second one is greater interaction with the electric or magnetic fields. Third one, less mass of the particle. And fourth one, all of the above. Magnitude of deflection of cathode rays in the discharge tube, it is depends on the magnitude of the charge, magnitude of the electric and magnetic fields which are applied externally, and the final one is mass of the particles. So based on these three aspects, the deflection of cathode rays, that means the particles deflection is depends on. So therefore, coming to the given problem, all the three aspects are correct. Hence the correct option is 4. The next question is, the E by M value of proton is, here are the options. The first one is less than the E by M value of electron. Second one is equal to the E by M value of electron. Third one is greater than the E by M value of electron. And the fourth one is all the above. When you compare this proton and electron, the mass of the proton is more than the electron. The E by M value of proton is less than the E by M value of electron. Hence the correct option is 1. The next question is, the alpha particles are, here are the options. The first one is high energy electrons. Second one, positively charged hydrogen atoms. Third one, nuclei of helium atoms. And fourth one, high energy radiations. The alpha particles are regarded as the nuclei of helium atom is known as alpha particles. This is the alpha particle 2He4. Hence the correct option is 3. The next question is, the correct statement about proton is, here are the options. The first one is it is a nucleus of deuterium. Second one is it is an ionized hydrogen atom. Third one is it is an ionized hydrogen molecule. And fourth one is it is an alpha particle. If you consider the hydrogen, this hydrogen is the simplest atom. It contains one proton and one electron. Suppose if one electron is removed from this, then it changes to H+. Now the protons present in this is one proton and the electron is coming out from this. So this is the equation. Therefore, an ionized hydrogen atom is regarded as proton because this species contains only proton. So therefore, an ionized hydrogen atom is regarded as proton, which is denoted by H+. Hence the correct option is 2. Next question is, substance having same number of electrons but different mass are, here are the options. The first one is isotopes, second one isobars, third one isotones, and fourth one allotropes. Here substances having same number of electrons. Number of electrons is given by the atomic number. So therefore, if the substance is having same number of electrons, which means the atomic number is same but different mass number is different. Therefore, substances having same number of electrons but different mass number are known as isotopes. Hence the correct option is 1. The next question is, the massive particle among the following is, here are the options. The first one is alpha particle, second one neutron, third one is proton, and fourth one is beta particle. The alpha particle, which is regarded as 2He4, that means it contains 4 units of mass. Deuteron, this is called the deuterium. This deuterium contains 2 units of mass, and proton, it contains 1 unit of mass. Beta particles, they are having 0 mass. So therefore, among the given particles, alpha particles, they are having, which are also designated as 2He4, having highest mass. So therefore, the correct option is 1. The next question is, which of the following statements is not correct regarding the cathode rays? Here are the options. The first one is, the rays carry negative charge. Second one is, the charge to mass of these rays is considerably smaller than the positive rays. Third one is, the rays produce mechanical effect. And the fourth one is, the charge to mass ratio is independent of the nature of the gas taken in the discharge tube. The specific charge, which is also known as the charge to mass of cathode rays, is greater than the positive rays or anode rays. Hence the correct option is 2. The next question is, which of the following is not the basic postulate of Dalton atomic theory? Here are the options. The first one is, atoms are neither created nor destroyed in a chemical reaction. Second one is, in a compound, the relative number and kinds of atoms are constant. Third one, atoms of all elements are alike, including their masses. The last option is, each element is composed of extremely small particles called atoms. So, according to the Dalton atomic theory, atoms of elements are alike, but their masses are not be the same. So therefore, correct option is 3. The next question is, if S1 be the specific charge, which is E by m of cathode rays, and S2 be the positive rays, then which is true? Here are the options. The first one is, S1 is equal to S2. Second one is, S1 greater than S2. Third one is, S1 less than S2. And the fourth one is, either of these. Given the specific charge of the cathode rays is equal to S1 and the specific charge of anode rays, which is equal to S2, we know that the specific charge or E by m of cathode rays is greater than that of the anode rays. While discussing about the anode rays, we have mentioned this statement. Hence, S1 is greater than S2. Hence, the correct option is 2. The next question is, the ratio E by m, that is the specific charge for a cathode ray. Here are the options. The first one is, the smallest value when the discharge tube is filled with hydrogen. Second one is, it is a constant. Third, varies with the atom number of gas in the discharge tube. And the fourth one is, varies with the atomic number of an element forming the cathode. Here, the specific charge, that is the E by m value of this cathode rays, is a constant. Whatever the material you kept inside the discharge tube, the E by m value of the cathode rays is constant. So therefore, it is independent of the material particle, that is the element. Hence, the correct option is 2. The next question is, the number of neutrons present in the deuterium isotope of hydrogen is. Here are the options. The first one is 2, second one is 3, third one is 5, and fourth one is 1. Deuterium is represented as 1H2. This is one of the isotope of hydrogen. Here the atomic number is equal to 1 and the mass number is equal to 2. These are represented as Z and this is represented as A. So therefore, the number of neutrons is equal to 2 minus 1 because the formula is A minus Z, which is equal to 1. Hence the correct option is 4. The next question is, the ratio of E by m of proton and alpha particle is. Here are the options. The first one is 2:1, second one is 1:2, third one is 1:1, and fourth one is 1:3. The alpha particle is represented as 2He4. This proton has 1 unit mass, whereas the alpha particle or 2He4 has 4 units mass. What we can say? The mass of the alpha particle is more, therefore it has less E by M value. Now, coming to the ratio of E by M value of proton to the alpha particle, the relative charge is taken as 1 unit divided by mass as 1 unit divided by, whereas the E by M value of alpha particles, this can be taken as 2 by 4, the ratio could be 2 by 1 or 2:1. So hence the correct option is 1. The next question is, which of the following contains more number of neutrons? Here are the options. The first one is sulfur 32, second one is sodium 23, third one is Fe, that means iron 56, fourth one is calcium 40. Sulfur 32, the first one is sulfur 32. The number of neutrons is equal to, as I already mentioned about this, the number of neutrons is equal to A minus Z, that means mass number minus atomic number. By using that formula, we arrive at 32 minus 16, which is equal to 16. So therefore, sulfur 32 isotope contains 16 number of neutrons. Now coming to the sodium 23, here the number of neutrons is equal to 23 minus 11, which is equal to 12. For iron, it is number of neutrons is equal to 56 minus 26. 26 is the atomic number of iron, so therefore, which is equal to 30. Similarly, for calcium, the atomic number is 20. The number of neutrons is equal to 40 minus 20, which is equal to 20. Therefore, iron 56 is having maximum number of neutrons. Hence, the correct option is 3. The next question is, one of the fundamental particle is missing in one of the isotopes, and the particle and isotope are respectively. Here are the options. The first one is neutron and protium, second one is neutron and tritium, third one is proton and protium, and fourth one is electron and tritium. Here the question is, one of the fundamental particle is missing in the one of the isotope. So here mostly the options contains the isotopes of hydrogen only. So therefore, among the isotopes of hydrogen, you first consider the protium. The protium is 1H1. In this, the number of neutrons in this protium is equal to 1 minus 1, which is equal to 0. So therefore, it has no neutrons. So therefore, the particle is a neutron and the isotope is protium. Hence the correct option is 1. The next question is, charge of the species with 17 protons, 18 neutrons and 18 electrons is. Here are the options. The first one is plus 1, second one is minus 1, third one is minus 2 and fourth one none of this. Coming to the charge of the species contains 17 protons, so therefore 17 into plus 1 plus 18 neutrons, the charge is 0, plus 18 into minus 1, which is equal to 17 minus 18, which is equal to minus 1. Hence the correct option is 2. Next question is, among 10A20, 11B21, 11C22 and 12D22, the isobar combination is. Here are the options. The first one is A and B, second one is B and C, third one is C and D, and fourth one is A and D. Isobars contains same mass number. Among the given species 10A20, 11B21, 11C22 and 12D22, both the elements C and D have the same mass number. Hence the correct option is 3. Next question is, which of the following elements exhibit more number of stable isotopes? Here are the options. The first one is hydrogen, second one is oxygen, third one is tin, and fourth one is sulfur, S. This tin exhibit more number of stable isotopes. Even the hydrogen exhibit 3 isotopes. Among these, the most abundant is protium, and the stable one is the first one and is second. So therefore, the stable more number of stable isotopes will be exhibited by the tin metal. So therefore, the correct option is 3. The next question is, the atomic weight of an element is 23 and its atomic number is 11. The number of protons, electrons and neutrons respectively present in the atom of the element are. Here are the options. The first one is 11, 11 and 12. Second one is 12, 12 and 11. Third one is 11, 12 and 11. And fourth one is 12, 11, 12. Here the atomic number is given as 11. Mass number, which is also treated as the atomic weight, which is given as 23. Therefore, The number of electrons itself is the atomic number. So therefore the number of electrons is equal to 11. Number of protons is equal to, it is also equal to the atomic number. So therefore it is equal to 11. Number of neutrons is equal to, which is the difference between the atomic number, which is the difference between mass number and atomic number. Therefore 23 minus 11, which is equal to 12. Hence the fundamental particles electrons, protons, neutrons respectively are 11, 11 and 12. Hence the correct option is 1. Next question. A neutral atom with atomic number greater than 1 consists of. Here are the options. The first one is protons only. Second one protons and neutrons. Third one is neutrons and electrons. And fourth one is neutrons, electrons and protons. For a neutral atom with atomic number greater than 1 has number of electrons is equal to Z. Number of protons is equal to Z, because for an element the number of electrons and number of protons are same, which is given by the atomic number. We know that the number of neutrons is equal to A minus Z. All these formulas already know about this. So therefore only for the element with atomic number 1 it has no neutrons. It has no neutrons. For the next elements, that means neutral atom with atomic number greater than 1 has some neutrons. So therefore these elements have all the fundamental particles. So therefore the correct option is 4.